tell you? Like a graph? Yeah. I was thinking like when you like plot revenge with someone. They're like planning revenge. But in math, when you hear plot, you guys were right. It's on a graph. We're putting a point on something. We're plotting that point. Okay? So a dot plot is a way to show data. On a number line. And generally, either you're going to be using dots or X's. Sometimes we might use other shapes, like, I don't know, a square, or if you really want to use like a W, you could, I guess. But generally, we're going to use X's or dots. Okay? All right, you're going to get a glue in. You can just glue this in right as it is. There's two problems on it, actually. I'm going to glue it in to the left side, and then I'm going to write on the right side, so I'd glue it on one of your sides. There's two problems on it. Go ahead and get that glued in. As you find your glue, you can go ahead and take out your pencils, color pencils. I'm going to use like all the color pencils. It's going to be fun. All right, so go ahead and get that glued in.
I'm sorry. I thought you were going to
I think I used that. All right, so go ahead and get that glued in. Thanks for being patient while I pass these out. I'm really slow. 1, 2.
Don't be rude.
Can I please have
You crumpled it.
Yeah, so give me a new one.
All right, so go ahead and get that glued in. There's two problems on it.
Do I need space on it?
You're going to want space like on the right or left side.
No, on this. Am I writing on this?
No, not necessarily.
Okay, so
If you really want to.
it's uneven.
Okay. Yes, if that bothers you. All right, so a couple of things about this is on our dot plot, we need one thing for sure. A title. Why do we need a title? Otherwise, we don't know what's going on. Beautiful. Love that. Okay, so in this first one, what's this first dot plot about? Minutes racing. Do you think this is the same person racing every time? No? Maybe? Does it say? No, it doesn't tell us who our sample is or what our population is, so we just know we have dots there. It's just a way to display our data. Let me make sure I get it back, because somebody stole my glue earlier. All right, so big thing here is we have to have a title. What do we call these numbers in between the title and these dots? Data point. Beautiful. So they each correlate with a dot. So as I look at this, I'm going to, again, use lots of colors today, so if you want to take out a color. What is my fastest time? Yeah, that one's a little confusing. When we think of this, we usually think of like what's the biggest, but fastest is actually the smallest amount of time. If you're going to finish that race first, you want the least amount of time, right? So what is my least amount of time here? 25. So that's my minimum. All right, what is my maximum? 40. Now, in this problem, the minimum and maximum are the first and last numbers. No. So we have to always look where the dots are. Okay, where is our largest dot, our smallest dot? Not largest, but the highest, the greatest. All right, so our maximum here is 40. So what would be an easy thing to find using our minimum and our maximum? Median would be like finding the middle. What measure do with minimum and maximum? The range. So range is easy to find, and in this one, if you're planning a race, you might want to know what is the range. How long is it going to be since the first person finishes to when the last person finishes? So we'll subtract 40 minus 25 is, I think 15. Well, you guys can't see that. There we go. All right, another thing that doesn't take quite as much time on a dot plot, what other measurement could we find really, really fast? Mode. Why could we find mode pretty fast? Yeah, it's visual. It's like which one has the most stacked. Yeah, this time we have two modes. And it's the numbers that have the most dots. And here we have 32. It has 2 dots and 38. Okay, we could also find our median by going high, low, high, low, high, low, but this one isn't necessarily the easiest way to find that. You guys have blue ones on your desk. All right, let's create our own. So if you want to do a little dash line across, you can, so that way you know that this is a different problem. All right, as we look at this problem, it's hits in a round of hacky sack. Do you guys know what hacky sack is? Is that like kind of that little like beanbag ball that you like hit with your feet or with your elbows or your knees, but you can't use your hands? Thank you. Yeah, you can use it right now. You guys actually, I don't think, have a glue stick. All right, good catch. So as we look at this, first thing we're always going to do is look at our data and decide what kind of data do we have. So what's our range of numbers? Are they all together? Are they really spread out? They're like pretty close together, though.
I thought you meant like no.
They're pretty close together. What's our lowest amount of hits in a round? 3. What's our highest? 12. So we need to decide on our number line, what should we count by? We're going to count by 1s, 2s, 5s. If we count by 3s, that's going to be really hard to tell. And just do 0, 5.
Just do 1.
Just do 1s. If you do 5s, you're only going to have like 4 tick marks, and we want to be as specific as possible without it being like over the amount of work. So if it's not hard to count by 1s, just count by 1. So I'm going to start with 3, and I'm going all the way up to 12. Which, if you're labeling this and you're like, oh my gosh, that's so much work, you can come out to my farm and do chores, and you'll realize this is not that much work.
You have a farm?
I mean, I just live on a lot of land that's kind of like a farm. We have a barn and chickens. You can come take care of my chickens. You can clean the coop out. There's so much poop. What?
You get a good egg.
Get a lot of eggs. Sometimes, if we get enough.
Yeah, 'cause we get good eggs from 2 chickens. We get a lot.
Next up, what we're going to do is I like to just go left to right. Some people like to look and see like how many 3s are there, how many 4s are there. I like to just go through, and that's why I really like a dot or a dot plot, is because I don't have to worry about going least to greatest. I can just make dots with these numbers that I see. Do you guys want to use dots or X's? Dots wins. All right, so I'm going to make a dot at 11. So right above that tick mark for 11. It's not going in between the 11 and 12. It's right on the 11. And then I have a 9. 6. Now when we make these dots, we want those dots to be relatively the same size, or at least the same height, showing that like there isn't one that's bigger than the other. Then I have a 12. I have another 6, so now I'm going to put a dot right above the other 6 that I had. Another 6. Another 12. And again, we want that one, that 2, to line up with the 2. Okay, 3 and 4. So, did we have any 7s? No. Should I erase that 7 then? No. Remember, if I don't have any dots there, that just means it didn't happen. The number 7 still exists in the world. Just because we didn't get a 7 on this round of hits doesn't mean 7's erased from all of the world. It's still there. So the dots just tells us how many times it happens each. Alright, I'm going to draw that line across. This time I'm going to do a solid line because we're going to switch up what we're talking about here. This time we are going to talk about stem and leaf plots. Stem and leaf plots. These ones are a little bit challenging, so if this takes you a while to catch on to it, it's okay. It's okay if you don't get it the first time we learn something. Important part is you keep trying. Or you put your phones away at least and try to learn the first time. What? Oh, there you go. Alright, stem and leaf plots. With stem and leaf plot, we create a table. In the left column is our stem. In our right column is our leaves, but we just say leaf because each of these numbers are their own individual leaf. Okay, a stem and leaf plot is a way to show data using place values. So place values is really important here. We're going to be breaking things up into like tens, hundreds, thousands, ones. We are not going to use the blocks. I don't have them. No. Generally, we don't use those in high school as much. Alright, big thing here is each leaf is connected to its stem. Each leaf is connected to, it's kind of funny, its stem. So when we look at this leaf column, each of these leaves are numbers on their own. They're all connected to their stem, which is in its row. All right, arguably the most important part of a stem and leaf plot is the key. So important. What does the key tell us? Like how it works, the answers, like how to read it. How to read the chart. So a key is really important because sometimes we're going to be working with thousands, sometimes we're going to be working with tens, sometimes we actually work with decimal points. Okay. You're going to get glue in. This is glue in. I'm going to put it on the next sheet because it's too big for me to put on this sheet. So, depending on how you want to deal with your life, I recommend putting it on the next sheet. We got 3 problems here that we're going to work through. We're going to just try to examine this first one and make sure that we understand the correlation between the data and how it looks. Yep, I'm doing this one on the next page personally. Me too. Personally. And save you guys for last this time. How exciting. I'll save you guys for last because I didn't grab enough. Can you pass that?
Think it'd be helpful, huh?
Why didn't you give this to us earlier? What? I could have organized my page and fit it all on one.
But we're gonna like make a big thing with this. I don't think it would fit in one. I tried. What? I'm just gluing it in. I'm gonna write next to it. Okay? Yep. Why not? Alright, so I'm gluing this in right here. Okay.
Can I use your glue again?
Yeah, 1 second. Give me a second.
I'm asking you to give that.
Yes.
Can you?
Yes. I coached softball for like 3 years. Yes. North and Apollo.
Do you remember Shaylin? Probably not.
Maybe. Alright.
Did you coach Apollo?
Yes. Like 10 years ago.
Yeah.
A very long time ago. Maybe. I don't know. You'd have to show me a picture. My brain doesn't work that low. Alright, this is where I'm going to use watercolors. So a big thing here is we have to have our key. So as we look at this one, let's look at our data. What is this data describing? Test scores is our first one. And we can see our numbers here, and so this makes it really easy for us to locate like 31. Where is 31 really located here? 3 and 1. So we can see that because we're given that data. But if we're not given that data, where we don't see all of those points, we really have to take a look at our key. So I'm going to just like highlight that. I'm good now. You can keep it there for a second. Alright, so our key means 3, 9 is 39. So in 39, what does the 3 represent? What place value? The tens. So our stem is the tens spot. And 9 represents the what spot? The ones. So if I take a look at 49, how am I going to break 49 up into 2 parts?
4 and 9.
4 and 9. I'm going to think about it as 40 and 9. So which row would I find that 49 in? The 3, 4, 5, 6, or 9? 4, because that 40 tells me it's going to be in the 4 row. And which one of those numbers represents 49? The 9. Okay, as I look at this row of these 5s, what do each of these numbers mean? It's the 1s, but what does this 2 actually represent? It's not just 2. What's the stem it's connected to? 5, so it's 52. And then what does the 3 stand for? 53. What does that 5 stand for? 55. And then 55. Good. Yep. Can you wait? We're almost done. Okay, then you'll have to make an e-hole pass. Alright, so next up we have this boiling point. So this is a different problem if you want to make a little dashed line there to show that we're moving on to a different problem. Okay, first thing I want to do is look at what this is about. This is about boiling points. What is a boiling point? Yeah, when something boils. So we're looking at probably liquids and seeing at what temperature does that liquid start boiling at. Okay, it's degrees Celsius, so keep that in mind as we look at these numbers. They might seem ridiculously large, but we're not dealing with Fahrenheit. Okay, so we're going to start by looking at our key. Our key tells us 1,5 is 1,500. This 1 is on the left side. That represents the stem. So all of these stems represent what place? The thousands. And then the 5 is the part of this 500. So this is the hundreds. All right, so a couple of things that are really easy for us to find using this stem and leaf plot is like our minimum and our maximum. All right, what is our minimum? Yeah, I'm going to go up to my least amount of thousands. I have 0 thousands. And what's the least number in that row? The 1. And so my minimum, it looks like 0, 1, which really means what? 100. I have 0 thousands, but I have 100. I have 1 in that 100 spot. What is my maximum? But I have some 9s here. Why aren't those 9s my maximum? Yeah, because it's just 900. This is the 2,900. And is 4,000 bigger than 2,000? Yeah, so this 4,100 is my biggest. So 4, 1 means 4,100. All right, now if I want to identify my mode, remember mode means most. I want to look for the number that's repeated the most amount of times, but it has to all be within the same row. So like these 9s don't count as 9s together. It's not there's 3 9s here. We're not looking at that. We're looking at these are 2 2,900s, and this is 1 900. So which number has the most repeated in a single row? These 1s. And these 1s would represent 100. All right, our last thing that we like to do with this is our median. All right, and so for median, I'm going to underline to do my medians. Or dot, I don't know what I'm going to do. We'll find out. All right, so for median, we go high, low, high, low. So I want to think, what is my lowest number here? We said that 1 with that 100. And I do a dot, apparently. And then what's my highest number? The 4,100. Then I go back to my low. I have another 100. Do I have any 3,000s? No. How would I show 3,000 if I wanted 3,000? 3, 0. But there's nothing there. So that means there's no 3,000. So now what's my lowest 2,000? Or my next highest 2,000? 9. Yeah, I have to go back to that 9. Then that 100 goes with 2,900. I have another 100 that goes with 2,600. 300, 2,400. I don't think so. 300 goes with 2,200. I still don't think that's right. 400 would go with 1,500 or 1,800? 800. So I have 2 that are in the middle. I have this 9 and this 5. So what do we do when we have 2 numbers in the middle? Good. Add them together, divide by 2. So 9 plus 5 divided by 2. Do we want to just do 9 plus 5 divided by 2? No. What does that 9 actually represent? 900, because it's in the 0 column, or row. But this 5 is in the 1 row. So it's not just a 5, it's not just a 500, it's a 1,500. I don't know. Yeah. Okay, so again, I like to use my calculator for that one. I like to use Desmos so I can see that I typed it in correctly. So I have 900 plus 1,500 divided by 2, and we get 1,200. All right, last one. This one we are going to create our own stem and leaf plot. Okay, first thing we're going to do as we create our stem and leaf plot is we're going to look at the problem that we actually have. Look at these numbers. we have to think, how are we going to split these numbers up into two place values? Are we going to do tens and hundreds, tens and thousands? You did it backwards, Doriana. Try again. Okay, well, it's not my issue. All right, so we're going to break these up into two parts. Do we want to do like the number and then the decimal point? Probably tens and ones. And the problem with tens and ones is as we look at this, if I have 59.2, what's the tens? The 5, but what would be the ones? 9.2. I'm looking at this one here, 59.2. And we can't have two numbers in the leaf. So we have to round. Okay? So as we do this, I'm going to actually rewrite this. And I'm going to rewrite them, but with my rounded answers. I'm going to round the nearest whole. Because we can only have two numbers. So 54.4, what does that round to? 54. 18.4. 18. 39.4 is 39. Now I'm just rewriting everything, so I'm going to just copy that 42 over. Because otherwise it looks like a mess over here. 31.2 rounds to 31. 57.8. 58. 68 is 68. 33 is 33. 10 stays 10. What about 9.8? That would round up to 10. 57.2. 57. 46.6. 47. 42.8. 40, what? 43? Yeah, I think I said 42, sorry. 52.4. 52. 59.2. 59. And 50.6. 51. So if you want to find exact numbers, like this 18.4 is really important that there's that 0.4 there, and that's a really important part of your data. Do you want to use a stem and leaf plot for this? Probably not, because that 0.4 gets a little lost. We just call it 18 because we had a round. All right, so now we're going to build our stem and leaf plots. I'm going to have stem on one side. Stem comes first, and then I have my leaf. If I didn't have my data attached to it, I would want to make sure I have a title, but because my data is just right here, it's annual precipitation, how much rain there is each year. Okay, what is my lowest number here that I need to represent? 10, so I'm going to start with 1 because we said we're going to do our 10s and our 1s. So our 10s place and our 1s place. And what's the highest tens place I need to get up to? I think 6. I think I have a 60 in there, right? So I have my 10s, 20s, 30s, 40s, 50s, and 60s. All right, now as we go, we want to organize it. We still want these leaves to go least to greatest. And this is kind of the pain in the butt about a stem and leaf plot. So I'm going to start with my 1s. I'm going to go through it, and I'm going to do this in rainbow color as requested. So I'm going to start with red for my 1s. So for my 1s here, I have a 10, and an 18. So I want to go least to greatest. So what is my smallest one that starts with a 10? 10, so I'm going to do a 0. And then I have another 10, and then an 8. Red, orange. For my 2s. I have none. Skip the 2s. Yellow for 30s. I have a 39, 31, and a 33. So as I list these leaves, I want these leaves to go in order least to greatest. I don't want to just start 9, 1, 3. I want to go least to greatest. So it's my smallest 30, 31, and then 33, 39. All right, next up we got G. Got green. I'm thinking right G-Biv here. Rainbow color was the suggested. It's making happy. Good. All right, 40s. We got 47, 43, and a 42. So in order, that would go 2, 3, 7. Rye, G, Biv. B. So we got blue. This one has a lot, so you have to be really careful with this one. We have 54, 58, 57, 51, 52, 59. So what is our smallest 50? 1, 51, and then 52, 54, right? 7, 8, 9. And then we got our purple, last one. Or indigo, if you have indigo. I don't, so I'm going to use violet. So for the last one was 60s. What's my last 60 I have? 68. So that just gets a 6 and then 8. Now we're not quite done. We have arguably the most important thing left. The key. We know how we made this, so we know how to read it. But if someone else came in, would they know? No. So we need to write that key out. And to do the key, we just pick any number that we want. I like to use a number that we at least used. So pick one of those numbers you really like. We didn't have a 35. Okay, pick one that's one of our numbers. What did you say? I can't hear you.
5.
But 5 isn't a number. Like 50 what? Like pick one of the original numbers.
42.
Okay, 42 is what is the first number that came out that was right. All right, so 42. So we're going to say when I have this 4, that 42, we represented it. We broke it up into a 4 in our stem, slash, and then what got put with our leaf? 2. So 4/2 means what? 42. I like to personally always use one that's actually in my data set. You do not have to. If you wanted to use like 23, even though we don't have a 23, you could. That is it for your notes today. There is a quick check today. It's 3 questions long. Shouldn't take you too long. As a heads up in this chapter,